2003 till 2012, Professor Gokhale was entrusted with the responsibility by the MHRD as the director of NIT Kozhikode, Raipur, Mizoram, and Nagpur. From 2012 till 2017, he was the director of the Lakshmi Nivas Mittal Institute of Information Technology in Jaipur, first PPP mode deemed to be university in Rajasthan. Professor Gokhale has served as a member on the working group for engineering segment of National Knowledge Commission in 2007-2008, as well as on the NIT Review Committee from 2012 to 2014. He is a trained moderator in SOAP German methodology for project planning and has carried out a number of workshops for public sector as well as government undertakings. Professor Gokhale is mentoring and advising a few technical institutes in the capacity as governing board and academic council member. He is currently the chairman board of governors of NIT Durgapur. Professor Gokhale was an adjunct faculty at Defense Institute of Advanced Technology in Girinagar, Pune for 1.5 years. He is a member for DRDO RAC as well as SAC SHC of AICTE. He is the chairperson board of governors of NIT Durgapur since August 2020. With great honor, I now invite Professor Sadanand S. Gokhale, Chairperson Board of Governors, NIT Durgapur, West Bengal, joining us online for the talk on the topic AI and robotics in aerospace. Over to you, sir.
Okay. So good afternoon to you all. I hope you are able to hear me as well as you are able to see me. I'm going to talk about artificial intelligence and robotics in the aerospace science. This is something slightly different from the theme on which this particular national conference has been organized. But then again, the computer science or electronics all by itself doesn't stand. It need to find out some outlet where you will be able to put the thoughts and processes or the system that you have developed, integrate it with the other systems, and then make it work. So what I'm going to tell you in another 45 minutes or so is my experience with the artificial intelligence and robotics. Okay. I'm not able to move to the next screen. My screen is frozen. I don't know why.
Try again, sir. Just close it and again redo it, sir. Or send to us by email. We will do it from here.
For some reason, my screen is frozen. I'm not able to move forward. I do not know what exactly is the problem.
Can you send it by email, sir?
Good. Okay. Finally, I hope you are still able to see me. Well, let us talk. I'm starting with the three entities which are hot entities these days. One is the civil aircraft. This is the Airbus 320 and Boeing 737. Both these aircrafts are in high demand. These are single aisle aircraft. Some of you might have already traveled in these aircrafts. In a year, about 1,260 aircrafts are prepared. Each aircraft costs somewhere around $130 million. And there are major components in this, are about 350 major components are there. The special attributes are about 4.5 billion passengers we carry every year. And in that particular year, the fatalities were somewhere close to just about 239. As a matter of fact, aerospace has got a very good safety track record. We have not lost too many people, and altogether, we are simply fabulous in comparison to the road fatalities. So the next comes is the automobiles. In the automobiles, world over 92 million automobiles in the price range of about $4,000 to $0.3 million they were sold. Automobiles, right now, you have got a very different type of automobiles. So we have got approximately 30,000 components, quite a bit of it, nearly 50% of it is going to be electrical and electronics. In the previous dispensation, in the Ford cars and so on and so forth, nearly 95% was all mechanical. What are the special attributes of it? There are about 1.3 million road fatalities world over. And the last one is a smartphone. About 1.5 billion were sold last year, and they cost anywhere between $100 to $1,000. There are major components again as 20. All of us are fully aware about the smartphones and the way in which they work and the way in which we have got addicted to it. What are the special attributes? About 1.5 billion people are using the smartphones on a regular basis. I come to the robot laws. This is Isaac Asimov. This is nearly 75 years ago when the space travel, etc. It started becoming a reality. Isaac Asimov, he wrote the 3 laws. A robot may not injure a human being or through inaction allow a human being to come to harm. So that means the protection of a human being is the primary responsibility of a robot. A robot must obey orders given by a human being, except where such orders conflict with the first law. So you cannot be telling kill me or anything of that sort, right? No suicidal type of a thing you would be able to allow you. Robot must protect its own existence as long as such protection does not conflict with the first or the second law. Very simple laws, but philosophically, they make all the sense, and you need to really work with it. So in mid 60s, there came a movie. HAL was a computer in that. This was based on the artificial intelligence and based on the book of Arthur C. Clarke's Space Odyssey. And it was a series, something like 3 odd movies were made. HAL, not Hindustan Aeronautics Limited, but it's a heuristically programmed algorithmic computer. This is a sentient artificial general intelligence computer that control the systems of the Discovery, one spacecraft, and interact with the ship's astronaut. That particular HAL's present was through this type of a lens, camera lens. Of course, this was a fiction, but the fiction fiction became a reality in real quick time. All of us are aware about the role that humanoids or human robots or U-bots, and they are going to make into your and my life during our lifetime. So HAL was given the over-constraint problem and solve as best as HAL can, and constraints were ensure the success of the mission, relay information fully and accurately, withhold vital information from the astronauts. And it's the third part, which really became a bone of contention, because one of the astronauts who stepped out, the HAL sort of thought, that he is going to harm the system, and hence he shut the door. That means the astronaut kept on floating outside. Those of you who have not seen Space Odyssey series, please do that. It is a wonderful sci-fi movie and much clean movie. It is not a ugly little type of a thing. So in the real world, industrial robotic applications, where all we can use it, drilling and fastening. If I tell you, that there are more than a million rivets in the Airbus 320 and similar numbers, even in Boeing 737, don't be surprised. So riveting is a very tedious and time-consuming job. Robot can do it. And all of you are familiar with 3-axis, 5-axis type of a robots. Welding for metal parts and heavy components, like a bulkhead, air duct, engine parts, you use basically TIG type of a welding. Sealing and dispensing, similar parts, dissimilar parts. That means in aircraft, you would have noticed, that there is a rubber, plastic, glass, and so on and so forth, right? It has to be infused with the metal. So that type of a sealing would be required, so that the air doesn't escape or outside thing doesn't enter into the aircraft, NDT, metrology and inspection of parts with a tight tolerance, Every time the aircraft lands, engineer is supposed to go around and find out, whether there is any leakage, whether there is anything, out of ordinary, that means there is a crack or there is a corrosion or anything of that sort, and he has to fix it. Rigid manufacturing, this is at the time of manufacturing, jig and fixture designs and parts and final assembly. Transport from one location to other for assembly and integration is another main thing about it. Aerospace is witnessing a very rapid growth, especially in India. Y on Y, year on year, the growth rate is in double digit, 10-11% and so on and so forth. Our honorable aviation minister, he is fully aware of it and he is pushing it, because aircraft is not the only aircraft that you need to worry about, right? You need to worry about where it is going to land, and then all the logistic, both from the air side as well as from the land side, and then air traffic controllers properly trained and so on and so forth. All those things are important, supply chain management is this very, very important, Aerospace is slower in innovations, It has made a lot of other things, I'm not talking about innovation means something which is radically different, Supply chain got badly hit during COVID. Indigo 30 aircrafts were grounded due to supply chain management issues in November of 2022. And Go Air is right now knocking on the doors of everyone saying, even though we are on the verge of bankruptcy, allow us some time. We want to float and we want to fly. Facilitating innovation. Stricter regulation doesn't allow risky sudden changes. Robot can allow incremental innovation. What is the basic aim? Productivity and boosting the efficiency. These are some of the pictures of the robots. It can do the airplane washing. It can do the propeller blade polishing, accurate hole drilling, multi-robot type of inspection, and so on and so forth. Unlike human employees, Kawasaki robot can detect minuscule variation in the thickness, patency, and integrity of aerofoil and aircraft skins. You might be surprised to know, that the skin, aircraft's wing skin, it is essentially thickish, somewhere close to the central part, and it becomes thinner on the outer side. Why? Basically for us, any saving in the weight is something which is critically important. Comes to the next point, we need to apply the paint, right? Airbus 320 adds about 250 kg of paint. So each kg, it cuts down onto your passenger or the facilities by which, you are going to carry more baggage and whatnot, So this is going to be really a major issue. So you would like to save everything as much as it is possible and then move forward, Repetitive tasks, including bolting, riveting, I mentioned it to you earlier, interior, external section, etc. This is the new concept, pilotless flying, whether you would like to be the first passenger, I doubt it, because we believe our brothers, right? The robot, if it is going to fly, you are not quite sure. And I mentioned it to you about the space odyssey, right? The robot takes it the other way around, it will become a little bit of a problem, So there are one or the two things, one is that total pilotless flying, robot is going to fly, he would be programmed and he will be able to learn from it, and then he will be able to do wonderful job from the safety point of view, So this particular thing is something important. I will talk about a little bit later, about the predictive analysis or predictive analytics, Autonomous combat aircraft capable of carrying out air-to-air, ground-to-attack mission. So for the military, this particular chap is okay because in military it is a risk operation, right? And then you would like to keep the human beings away, human beings safe, Pilotless flying, I mentioned it to you. Single pilot instead of two pilots, Can we do that, And then digital assist or remote pilot from the ground, he might be able to do things, As such, the unmanned aircraft systems are making a big input into the flying technology, flight technology. Personalized transport is something important. Unmanned aerial vehicles or the drones, for quadcopter type of a drone or last mile delivery type of a drones and all that, they are becoming very, very important. I'm not going to talk about that in this particular lecture. This is the one less pilot. Notice, the person who is sitting over here, the pilot who is sitting over here, he has got hands off. That means he is not touching anything, he is just supervising. And he can show this, the computer can show this, and we are talking about Airbus 350-1000, pretty expensive aircraft. It does use the image recognition technology. There are a lot of sensors and cameras, and it can take off automatically in the Toulouse airport in France, and this one was tested in 2019, So this thing is becoming a reality. Space robots, unmanned space system, as I mentioned it to you, identifying landing sites, difficult terrain for smooth landing, identifying some good part, where you will not be facing too much of a problem, landing sequence, because the speed at which, you are going to land, it will decide whether you will be able to survive that impact and so on and so forth. Unfamiliar environment, because you do not know what sort of atmosphere is there, whether it is corrosive in nature, radiative in nature, and so on and so forth. Communication to and from the robot is important, in situ analysis and data transfer, and the power requirements, all these things, they were used in the Mars mission. Next couple of slides will show you a little bit about the Mars mission. Robots to explore unknown environment and having a breakthrough technology. Ingenuity helicopter on Mars is designing of the next generation helicopter. Humans and robots to complement each other, AI capabilities, and the human's intelligence, or intuitive type of the computer will not be intuitive in nature. Only human being will be intuitive in nature. So this is going to be something which is going to be a force multiplier. Advanced robotic software for the autonomous systems continuously expand the capabilities and so on and so forth. So these are some of the pictures of the robots or the vehicles, which are on the foreign a planet or an asteroid or some such place, you know. They have to survive, you know, because there are no paved roads, right? You know, and you need to have a sufficient power source and so on and so forth, you know. So this is very, very delicate operation to the extent that you have to design all these contraptions on the ground, and then you have to operate it in an environment which is totally unknown to you. You know. This is Mars, and the one that you see over here is Perseverance. You know, Perseverance is about 3 meter long, 2.7 meter wide, and 2.2 meter tall. So this is almost like your SUVs, right? And this joker is called as the Ingenuity. So this is a coaxial helicopter with a mass of just about 1.8 kg and a rotor diameter of 1.21 meters. It relies on the solar cells and a battery system for power, allowing about 90 seconds of flight endurance. This was essentially supposed to be only technology demonstrator. And when this particular thing was achieved, NASA was mighty thrilled, and then they jumped saying, you know, this was the first flight moment on Mars on this exactly similar fashion as at which, you know, in 1903, Wright brothers flew. So this is Ingenuity, you know. Under development is the next generation helicopter with a mass of 31 kg and a payload capacity of 2 to 5 kg. You know. So what is this Ingenity's technical specifications? Some of them I already showed it to you. You need a battery, and the flight range is just about 300 meters, and it can fly up to something like 5 meters. You know, as I mentioned, it was for a technology demonstrator, right? But this guy, you know, Ingenuity, he has completed 50th flight in April 2023. In 4 years, was able to have 50 flights. You know. So this is a breakthrough. This is a technology breakthrough. Why so? Mars gravity is 0.375 that of the Earth, and Mars atmospheric density is something like 0.020 kilogram per meter cube, which is equivalent of you flying something at a altitude of something like 35 kilometers. This is very, very risky. Do the humans fly at the 35 kilometer? Doubt it. Military, maybe, but not otherwise. You know. This is the latest news. You know. This is the Airbus drone called as the VSR 700. So they have successfully sea tested this particular autonomous drone. You look at nothing fancy about it, you know, regular helicopter-like thing, but there is no pilot, right? And there would be some instruments over here, and then the pylons, you know, where you will be able to land, you know. What are so critical about it is the wind speed is exceeding 40 knots, which is characterized as a strong gale. It was able to withstand that, you know. Or it was flying on basically on the seaway, you know. So high waves of at the sea to the range of about 7 to 10 meters, you know, it is able to withstand it, you know. This is something unique, you know. You know, when you want to have a rescue operation and so on and so forth, how do you do that, you know? This drone is powered by, you know, the technical details, you know, I think I will skip. You know, it can have the payload capacity of 100 kg. And more importantly, it has got an endurance about 10 hours, almost twice that of the standard helicopter. And a rotor drone could be a crucial force multiplier needed at the sea, you know. So if you are going to have such a long endurance, you know, you have learned something from a bird. And that bird is basically albatross. Albatross keep on flying on the sea for hours and days and so on and so forth, you know. So from that, you know, you try to learn, you know, saying, you know, how I will be able to replicate its flying, you know. Again, a little bit of a technical detail. The drone that can fly very, very high, these are the last two ones, you know. These are the common military drones, you know. Okay. And they fly somewhere around 10,000 feet altitude, you know. These are some of the robots, you know. I showed it to you earlier also. You need to have a robust robot, you know, because the terrain is not known to you. So it should not topple, you know, because the center of gravity, etc., you try to work it out, you know. you have to have this particular contraption which will be able to keep the balance and do the work. It has got basically a camera, and then it will be able to work. You remember, you might not be be familiar with it, but this was from again another sci-fi movie, R2D2. So this was a robot, and this is your current Android markup. Look at the similarity between the two. So you learn something, from the fiction, and then you try to incorporate it here. Long distance communication. This is something very interesting. The gripper on the European Space Agency's rover on the Earth, this robot is on the Earth, and it has been controlled by an astronaut in the space, like International Space Station and so on and so forth. From there, he is able to manipulate this particular robot. So this is where the robots are going, and they are going in a big way. Autonomous robot systems, you would know probably a little bit more in this course of time. For the want of time, I will not spend too much of a time over here. Sensing and situation and self-awareness and reasoning and acting, that is reasoning plus control. These are the two important things. So you perceive something, the goals will be decided, and then you act, and whatever the feedback loop will tell it to you, saying, that go back to the perception, and then you try to modify it. So autonomous robot systems are essentially in a position to do this type of a work, and in which, artificial intelligence is playing very, very key and important role. I will just concentrate on this particular box, For nearly more than 50 years and so on and so forth, Hubble telescope has been roving around the Earth, is going from planet to planet, taking pictures and then sending those pictures, to the ground, and scientists are able to decipher the information that has been sent to us. The latest one is a Webb telescope, and that is going a step or two steps beyond Hubble. Some of you might have heard about the Voyager 1 and 2. This was launched in 1977, two Voyagers, and they have traveled and they have traveled, They are continuously traveling, 45 years in the space and still active, well and kicking. They are something, to be sort of proud about, scientific achievement per se. Independent of the external control is a broad definition of autonomy. So you have to have a self-directedness and self-sufficiency to operate independently. Self-sufficiency means the power requirements and the well-being of that particular thing. It might be interesting to know, that this perseverance that I told you to you in the initial stages, because on Mars also you have got storm, right? So they have got solar panel, for the battery recharge. So there was some dust accumulation, Would you believe, this ingenuity went and blew the dust away, because it has got those big little rotors. So it went and then it cleaned up, not by hand, but by blowing it away, So this is something which is very, very important. Curiosity rover can autonomously drive from point to point using stereo vision and onboard path planning. So suppose if you come across, some sort of obstacle, you should be able to find. You will not be able to climb the obstacle. It's not like you climbing up to the Mount Everest and all, but you have to circumvent it. You go around it and so on and so forth. Okay, I'm closing on this robot. This is modern times. Another fictional movie, Charlie Chaplin movie. Those of you who can lay your hands on, please do that. It's nearly 90 years ago, and was trying to bring in the perils of the automation. In those days, and automation was just beginning. It was nowhere close to where we are right now. So the social message through the creative art, is the theme. that I thought that I will just show it to you. Coming to my aircraft systems and where the this big thing is going to come about. So in the aircraft, you have a mechanical, hydraulic, pneumatic, electrical, electronic, electromechanical systems, and in situ data processing for autonomous system or the autopilot. So all these things, they are very much inbuilt, into the aircrafts. What are the key features? Reliability, reduced system inertia, miniaturization, and weight saving. All these things are very, very important. We cannot afford to have redundancy, because the redundancy, except for the very, very critical component, because redundancy will essentially add the weight, So we do not like to have redundancy. And mechanical systems have got a large inertia, whereas the electromechanical system, which is a current train, it is lighter. I'm going to show you some of the critical things. This is my aircraft in a pitch, in roll, and in yaw. And the control surfaces are shown in the black, and those things, So it is a 6-degree freedom type of a thing. There are 3 forces and 3 moments. So 6-degree freedom. What are the critical features of the aerospace or the aircraft? To be precise. Low factor of safety, thin wall pressure vessel, minimal redundancy from weight saving. I mentioned it to you. Operating conditions are trying and continuously varying. 6 to 8 landings for a short haul aircraft. Must withstand vagaries of the weather, turbulence, storm, rain, snow, etc. Error resulting in the catastrophic failure with the loss of life and the hull. Hull means, the whole aircraft is lost. Large scale integration and excellent safety record. So these are some of the positives and critical issues that you need to really figure it out. As I mentioned it to you, the low cost carriers, like Indigo, they do something like 8 landings in a day. So what is the typical sequence? You are flying from the ground. Let us say you're at the ground, you have got a 1 bar pressure, 1 atmosphere. When the aircraft starts flying at somewhere close to about 10 kilometers, which is the cruise altitude, the outside pressure drops to something like 1/4 of that of your sea level type of a pressure. Now, that type of a pressure, human being will not be able to withstand. So inside, you have got a climate control. Outside, the temperature might be minus 70 degrees Celsius. Inside, the temperature is going to be 24 degrees Celsius. So from the passenger comfort, you need to have this particular environment control, Now, suppose if I say, that you are going to have 8 landing, that means the pressure or the temperature cycles are going to be repeated almost like 6 to 8 times, So you can imagine, what sort of a load, varying load this aircraft is going to go through. On the top of it, in the engine, the temperature in the core of your combustor is fairly close to about 1500 degrees Celsius. Outside, again, as I mentioned it to, minus 70 degrees Celsius. You need to have some sort of connectivity between the outside and the inside, and you should be aware about the fatigue that would be setting in terms of this repetitive mechanical loading as well as the thermal loading. These are some of the sensors. You've got a color sensor, gas sensor, LDA, then touch sensor, IR sensors for transmittive and reflective type, heartbeat sensor. All these things are required for the space travel. Soil moisture sensor, ultrasonic sensor, and so on and so forth. There are active or passive type of sensors. Detection are electrical, biological, chemical, radiation, radio. These are the parameters that you are trying to monitor it. Conversion from photoelectric, thermoelectric, electromechanical, etc., to readable format, and processable format, So that means, you need to have quite a few of these systems. I would show it to you next. They are analog in nature. You need to convert it into digital for processing purpose. Where do you use machine learning and artificial intelligence applications in the aerospace? Optimization method, robotic and semi-autonomous space operation, shared autonomy in the human-robot interaction. I showed it to you a little bit. Then robotic missions, sensors and actuators, application with the limited available data, Substituting physical testing with the algorithmic or the numerical testing saves money, saves your effort. And for UAVs as well as the space travel, trajectory optimization is important. So if you talk about the data or a big data, as they call it, so why do we need the data? That is question number one. What form is important or the critical data? You don't want to collect garbage, right? No. How to collect, acquire, store, and process the data. When to collect the data, during or the after flight. Where is it used, in situ, post-flight analysis, etc., etc. So these are some of the critical issues. These are the places, where the sensors are going to be located. Flight control and actuation, cabin, galley, and cargo, because this is pertaining to internals of it. Cockpit control, pilot is going to be needing all these things. Then engine turbine, because without the engines and turbine and the thrust, you will not be going anywhere. Landing gear and the brakes, because what goes up must come down, and every time it has to be safe. So this is something which is very, very important. In aircraft, we always make a statement, saying two statements to be precise. One of which is that we make money only when we are up there in the air and come back safely and touch the ground again. That is axiom number one. Axiom number two is that in you know that in the cabin there are two pilots, captain and a co-pilot, right? So you should not be having a fight over there. It is not who is right, but what is right. And these are the two basic dictums, through which the aircraft industry progresses. This is the old-time basic cockpit instruments. Starting with this, this is the airspeed in knots, not in kilometers or mile. Then this is artificial horizon. Then this is altimeter, at what height you are flying. Climb rate, rate of climb, rate of down, so up and down, rate of descent and rate of climb. Then this is a direction pointer, and this is a turn coordination, whether you are doing a left pitch or a right pitch and so on and so forth. This is typically the Boeing 787's cockpit. You just sort of, it is meant for you to understand the complexity in it, so many switches, so many dials and so on and so forth. And pilot, he has to essentially know where is what and then try to address it. There are two screens, over here, which are identical. Okay, and this is the stick with which you will be able to control the up and down and left and right turn and so on and so forth. Anyway, I thought that I would just show it to you how complex it is. So there are three basic kinds of instruments, flight instrument, engine instrument, and navigation instrument. So easy to understand. This is the older generation analog instruments. Most of them are in a brass. This is for pressure measuring. This is again pressure measurement. This is gyroscope, and this is thermal measurement and so on and so forth. This is a boron tube. So very simple analog systems. We have been using it for a real long time. They have been now replaced. Look at this particular small thing, that I'm showing it to you over here. This is InvenSense's 9-axis motion sensor incorporating 3-axis gyroscope, 3-axis accelerometer, and 3-axis compass on the same chip. You see how all those instruments now you have been able to put it in the one single chip. This is something that has happened. So typically, again, these are the sandwiches, in which these types of devices are going to be locked in, and then for the safekeeping. And you have got position sensors, in terms of linear variable differential transformer or rotary variable differential transformer. There are load sensors, to measure the lift of the plane, and that on the landing gear, because it should not exceed. There was one funny thing, that was shown. The aircraft was so overloaded, that the pushback couldn't be taken care of, So they have to offload some weight and so on and so forth before it could really fly off, Sensors, they sense the physical changes, and transducers, they convert this physical quantity or non-electrical to another signal or electrical signal, oscilloscope, calibrated meters, dials, etc. Three major components: input device, signal conditioning, processing; output device such as a thermocouple or a thermistor. You have to use these sensors sensibly and effectively, because the sensors are becoming smaller, they are becoming smarter, and they are becoming cheaper. So sensor technology enables validation of design tools, new product development, engine control, health monitoring, etc. Sensors have to survive these extremely varying and a repetitive type of a condition. Sensor stability and the projected degradation needs to be taken into account. Any mechanical system, over the use, you would notice it, it will continue to sort of performance will go down, So you need to really look into those things. I will very briefly touch upon this. Most of the data in the raw form will be from the analog instruments. Okay, this has to be converted into the digital format because the onboard computer doesn't understand the analog instrument output. So you need to do the first A to D conversion. On onboard computer, he would compute the thing and then send it back. And that has to be converted back into analog, And that would be essentially moving a particular control surface by a finite thing, Vast amount of information related to flight during the entire course is critical in case of accident or malfunction. Temporal and spectral tracking is essential. When it happened, how it happened, and so on and so forth. Large volume of data collected and analyzed and used. Safety of the aircraft and predictive mode. This I mentioned it to you. I will talk to you about the predictive mode. Suppose if I am collecting this data on board while I am flying, and then I am transmitted back to the ground station, and the ground station has got a sort of a comparative tool whereby they will be able to say that this particular parameter doesn't look good and it needs a correction, and what sort of a correction is required, etc. That is called as a predictive mode. Broad perspective. Again, I will skip quite a few of these slides. GE CFM 56 is the largest engine that has been used by number of airlines all over the world. Data collected through 280 parameters. Your engine has got a 480 parameters. In key flight phases, such as the takeoff and cruise, GE fleet generates 100 million records per year. GE has access to 50 million variables from 10 million sensors. I'm just putting things, numbers in perspective. You want to have a big data, you would be able to get tons of it, in the aerospace science. New aircrafts are fitted with more data generating sensors, while the Airbus 320 family can generate around 400 points of data. 330 has got 1500, and Airbus 380 has got 25,000. Both engine as well as the airframe, they are going to be essentially watched carefully. Engine performance degradation, fuel consumption, or increase the increase or decrease in the given thrust, increase and decrease in the maximum temperature that is allowed. These are the some indicators that you need to critically look at. Airframe deterioration, seals and doors, vibration, excessive vibration, flaps, rigging, spoilers, rigging, etc., etc. So these are something which is important, which you need to essentially. So this performance monitoring essentially is for the engine as well as the airframe, both of them. Result of aircraft performance monitoring is used to reach the following objective: to conceptualize the flight plan, finance management system predictions. Right now the Go Air is struggling with that particular part. Because passengers have lost confidence. The leasers, they want their aircraft back, and you need a minimum mass, for aircraft to become successful, That means you should have minimum number of aircraft, and the aircraft should have a maximum amount of seat load factor. And that seat load factor is, that means 85% of the seat should be occupied and paying, So 85 to 90, that makes you breaking even. So identify the possible degraded aircraft and maintenance action and route restriction. Suppose if uh, you know that your aircraft might not be able to travel such a long distance, then deploy it, because if you want to if you keep it out of service, then obviously you are going to lose a lot of money and so on and so forth. Maintenance, critical component monitoring, flight route sort of a modification. Indigo does this particular thing very successfully. They have got their own weather monitoring office, in Gurgaon, and they essentially try to make sure, that you do not have to go around, because if you, let us say, a flight start, you come over there and then there is a sudden storm is one thing, but if the weather is somewhere predictable, then try to avoid that particular thing, Types of data, you have got a big data, metadata, real-time data, machine data, and structured data. Qualitative is a fuzzy one. Quantitative is anything that is measurable, you are aware of that, And analytical tools are regressional analysis, which we do it, in terms of curve fit programs and so on and so forth, multivariable, and Monte Carlo simulations, factor analysis, cohort analysis, cluster analysis. I will not be able to go into the details of it. Data analysis techniques, time series analysis, sentiment analysis, and process defining questions, collecting, cleaning data, analyzing, and visualizing data. Currently, where and how we are using it, role of big data in the aviation industry. Centralized view of the customer is something which is important, optimizing the flight route, of course, demand forecasting, so in the summer month, should I have more aircrafts, on this particular route or whatever? So that is demand forecasting. Customer segmentation. That means, in my aircraft, how many should be first class, how many should be business class, how many should be economy plus, and how many should be economy. So this is a customer segmentation, depending on the paying ability of people. Fuel efficiency. Right now, the sustainable aviation fuel is making a big role. Just last week, in Pune, they operated a flight, between Pune and Delhi with the sustainable aviation fuel, and 1% only was added. So that thing is important. Fuel efficiency is important because that costs money. Giving out personalized offers, the flying returns, etc. What you know about, that particular thing. Smart maintenance, performance measurement. These are important. The artificial intelligence having all sorts of these things. This is from NASA, autonomous systems. Deep learning, predictive analysis, transition, classification, clustering, information extraction, speech to text. NLP is there, text to speech, expert system planning, scheduling, robotics, and image recognition, machine vision. All these are part and parcel of your artificial intelligence. You have to figure it out, which one fancies your interest. Yeah, in the airline industry, revenue management, air safety and airplane maintenance, feedback analysis, measuring or messaging automation, crew management, etc. So some of the major airlines, Delta, Air France, Alaska Airlines, Southwest, they have started using it in a roundabout way. This is essentially the sale point, for your flyers as well as your investors, whoever has put the money. Reducing CO2 emission, is good for the business. So you have to announce it in so many words. Better customer experience, more passengers will fly your aircraft. This is something, yeah, personalization, you know. Everybody has got this type of a mobile, right? So you go and you sort of focus it at a particular point, and then you will be able to get the relevant information only pertaining to your flight program, you know. Okay. Otherwise, what happens? If you go to the airport, you know, there is a big display, and you got to search, you know, where is your flight and which gate and so on and so forth. Here on your mobile, you know, you are able to get all the information. Your gate is 21. You would need 30 minutes to walk in this direction. The toilets are also available, etc., etc. You know, personalized information, you know, something which is important, you know. Okay, a little bit about the blockchain and predictive maintenance, you know. It's a digital ledger. Right from the birth of the manufacturing unit, it records the history, such as mean time between failures, MTBF, how often the part is replaced, by whom, when, and where. It records the credentials of the technician who performed this replacement, repair, and update every time instantaneously. Such a birth certificate creates a digital twin of an actual aircraft, and when aggregated, can predict and schedule maintenance. So this is the approximate flow path. You know. Aircraft is manufactured by a company A. I am now being a little bit specific. The Boeing Corporation makes a Boeing 737. It is sent to India, you know, and let us say, not Go Air, but SpiceJet is operating that particular thing. You know. SpiceJet operates the flight to international also, right? So when they go to, let us say, Malaysia, you know, the aircraft develops a snag. Now, you cannot ask the Boeing person to come and fix the snag unless otherwise it is that very critical and crucial. Okay, you cannot send your maintenance crew over there to Malaysia to fix it. So now you got to depend on the maintenance engineer who is in Malaysia. Okay, and he would have a part E, which is to be certified by F for the flight worthiness. You know. So you see, you know, the when we are talking about the flow path, you know, this is what is required. You know, sort of. Loss of flying time, loss of revenue, poor confidence of the passengers, Boeing 737 MAX, Kingfisher, Jet Airways, all of you are aware of all these things. Cooper, you know, they have got a nice little article on this, you know, those of you who are interested, this is a 2019 article. Part traceability, technicians, identity and credential, location and type of the service performed. What I was mentioning it was the other way, you know, real-time snapshot of the aircraft configuration and across the fleet. I will just rush through you. I'm not going to spend any time. You know, aircraft gas turbine engine is one of the most complex piece of contraption, you know, that you can ever find. You know, and these are basically the points, you know, which you need to pay attention to. 50,000 G centrifugal acceleration is exercised over here. 100 G casing vibration, then 10,000 RPM at 0.75 meter diameter. Why I'm showing it to you, the thermal and the kinetic loads on the gas turbine engine, they are phenomenal, you know. And you need to really do something to monitor it very, very critically, you know. And it is this particular gas turbine engine that the non-delivery of it, you know, has ran into, you know, has forced Go Air into some sort of a troubled environment. You know. So where are the new and innovative innovations that in the aerospace one can experience? Hypersonic flight to reduce the traveling time from the environmental concern as well as the ecosystem. Then the space tourism, Virgin Atlantic to Blue Origin and SpaceX, you know, all these big wigs, you know, they are willing to take you up for a notional fee of $500,000, you know, and a joyride for about 10 minutes, you know, will take you to the edge of the space that is about 80 to 100 kilometers from the surface of the Earth, and it will bring you back, you know. Smart materials, these are shape change alloy for the in situ repairs, you know. Especially, you know, if you talk about the International Space Station, you know, it is running successfully, but it is likely to be phased out by the end of this particular decade because it has lived its life, you know. But now if you want to repair it, you know, now you cannot be every time carrying, you know, or you cannot be bringing the International Space Station to the ground either. So you should be able to do this particular repair work, while you are up there in the space. Newer materials, lighter materials, radiation resistant materials are required. Then space mining, rare materials from the asteroids is something important. High altitude pseudo satellites, alternative to the geostationary, autonomous aircraft and drones, legal and ethical issues. We don't have time for that. So these are concluding remarks. Artificial intelligence, machine learning, IoT. These are no more buzzwords. But in reality, they are taking you from Industry 4 to Industry 5.0. Robotics will play a house. It will become a household entity, more affordable with ever increasing capability. Data science will be prevalent in all walks of life. Augmented and virtual reality coupled with the 5G network 5G network world will lead us to the next generation of integrated knowledge society. With this, I conclude my almost like a 1 hour talk, and I hope you people were able to get the gist of one of the critical areas which uses high-end type of a technology. Mind you, this particular technology that I am talking about, it is an existing technology. I have not developed anything new. I have not invented anything new. Aircrafts are there in practice, for past 110, 120 years, the space science is there for past, say, 60, 70 years. So all these things, they are happening, they are already existing. What is required is putting them together, in the innovative way, so that not inventive way, innovative way to take care of your future needs. With this, I thank the organizers of this particular conference, and then giving me the opportunity of spending some time with you. Thank you very much, Professor Sojanlal. Thank you. Thank you.
Thank you so much, sir. It was really an enlightened session covering lots of aspects, and you have even started with your career with aerospace itself from IIT, and also all the way you carried away all the things, and also you have presented whatever is existing that is actually we are looking for. Though there was a little glitch of the frozen the screen, so our participant could not see that. I'll try to get the PowerPoint from sir, and if he allows, I'll send to all the registered participants through email. So due to the shortage of time, I'm not taking any questions now, but if you have any questions, you can write to me, principal@mbits.ac.in, so that I will share and with the Professor Gokhale sir. So namaste, sir. Thank you so much being with us.
Thank you.
Thank you. Thank you so much.
I'm leaving the meeting, please. Thank you.
Yeah.
Thank you.
Okay, thank you all. And we will continue the session in the normal mode, in the offline mode. So I'm closing this recording session as well as all the proceedings also. So we'll go to the APJ Abdul Kalam Hall to continue this. Sundarji, we'll see you tomorrow online. Sundaresan Pulingam, sir. Namaste.
Sir, is it for tomorrow? I thought it is today.
Yeah. Oh, okay. Today. Oh, sorry.
Yeah, it's 2:30. Yeah, I joined already.
Okay, sir. We'll continue. I'm sorry about that. We will continue the session. That's my
Yeah. Okay.
By the way, to my colleagues, kindly put off the recording, please. All my colleagues, kindly put off the recording. MBITS Computer Center. Close the recording, please. Yeah. So kindly do not switch on the recordings. Okay. So over to the session for introducing Mr. Sundaresan Pulingam, sir.
Sir, you're able to see my screen?
Yeah. Perfect, sir. Maybe if you have a display mode, you can go to the display mode. Slideshow mode.
ಏನಂತ ಗೊತ್ತಿಲ್ಲ ಲಿಂಕ್ ಬಂತು ನನಗೆ ಮೇಲ್ ಅಲ್ಲಿ ಲಿಂಕ್ ಕ್ಲಿಕ್ ಮಾಡಿದೀನಿ ಬರ್ತಾ ಇದೆ
Ritika, are you introducing?
Yes, sir. Okay.
Yeah, please go ahead.
We are pleased to introduce Sundareshan Puvalingam is a distinguished technologist of Strategic Technology Group.
One second, hold on. Please close the live session, please.